Hi Science 30s, Mr. Riley here. We're going to do a quick little video looking at what's called Ohm's Law. So what Ohm's Law is, it's a relationship between voltage, current, and resistance. And it was defined by this guy named Ohm, George Ohm. And the formula for Ohm's Law, it looks like this. Voltage is equal to the product of current times resistance. And just a reminder, what are these different symbols? V is voltage, it's measured in volts. I is current, it's measured in amps. And we just did a video on resistance, which is measured in ohms. Now, when we are looking at this law, there's a couple of different things we can think about it. Number one, I might ask you to manipulate this formula. So if you have to solve for I, you can do, I'm going to divide both sides by R, so I'm going to get V over R. Okay, and if I want to solve for resistance, I'm going to get V divided by I. Okay, so you might be asked to do one of those operations as well. Now another thing to think about when we look at this, and this actually relates to looking at the resistance stuff that we talked about last time. If I increase the resistance, the current is going to decrease. Okay, with rising resistance, there's more resistance to the flow of electron current. Therefore, there's going to be less current. Okay, and another way to look at this is if I'm talking about current and voltage. These would have a direct relationship. So if resistance remains constant, if I increase the current, I'm going to increase the voltage. So a couple of graphical ways to look at this formula. So we're going to do two examples here. One sort of easier one and one a little bit tougher one. So the first one here says calculate the voltage across a 200 ohm lamp on a 15.0 amp circuit. Okay, so let's highlight the information that we have. So we have a 200 ohm lamp. Okay, so that's our resistance. 200 ohms. We have a 15 amp circuit, so that's our current. I equals 15.0 amps. And then we want to calculate the voltage. Okay, so simple three variable formula here. V equals I times R. So I'm going to take my 15.0 amps, multiply that by 200 ohms. Okay, I'm going to plug that into my calculator. 15 times 200, and I get 3,000 volts. Okay, so let's say, okay, I want to have 3 sig digs here. Okay, I'm going to move the decimal place 3 places to the left. I'm going to get 3.00 times 10 to the 3 volts. Okay, there you go. That's a lot of volts. Okay, let's look at a little bit tougher example. We're going to bring the resistance calculations that we talked about into this one. Okay, so this says find the total current flowing through the circuit. Okay, so if I was measuring an ammeter here, if I had an ammeter right here, this would measure the total current running through my circuit, right? This is a parallel circuit. So I have, one flow of electrons shown in purple here, and then I have another flow of electrons, I'll show it in green. Okay, and where those both overlap, anywhere where I have green and purple together, I could put an ammeter to measure my total current of the circuit. Okay. The voltage of this circuit is something that I would have to be given ahead of time. So let's say my voltmeter here is measuring, let's just say it's 9 volts. And so let's take a look at what we have and what we need to find out. Okay, so it says find the total current running flowing through the circuit. Okay, so we want to find the current. Okay, we have the voltage. Okay, so the voltage across my source or my batteries, okay, that is the total voltage available to my circuit. Okay, it's the rise in potential energy, or the rise in voltage from one end of the battery to the other, that's the same as the amount of voltage drop I'm going to have throughout the rest of the circuit. So my voltage is 9 volts. Okay. Now my resistance is I have two resistors here. So I have a 10 ohm resistor and a 20 ohm resistor in parallel. I'm going to have to do something here. So, and we need to think back here to find, first we're going to need to find R total. Okay, so if we remember from learning about resistance, if I want to find R total, I'm going to do 1 over R1 plus 1 over R2. And I'm going to get, okay, 1 over 10 plus 1 over 20. Okay. So plug that into my calculator. Okay, 1 over 10. Okay, multiply, or sorry, add 1 over 20. Close my bracket up. Okay, and I get 0.15. Okay, so remember, I don't want to solve for 1 over R total. I want to solve for R total. So if I want to solve for R total, that's going to be equal to 1 over 0.15. So I'm going to plug that into my calculator. Okay, I'm just going to do 1 divided by my last answer, which is 0.15, and I'm going to get this. So 6.6 repeating. I'll put 6.67. Okay, so that's the total resistance. So now that's what number I'm going to put over here, 6.67 ohms. So now I can use Ohm's law to calculate for I. So if we look up Ohm's law, it's V equals I times R. I'm going to have to manipulate that formula, solve for I. So it's going to be I equals V over R. My voltage is 9 volts. My resistance is that 6.6 repeating. Okay, so then I'm going to plug that into my calculator. Okay, so we've got our 9 divided by 6.67. Sure, that's good enough. Okay, and I get this, 1.35. Okay, so my total current is 1.35 amps. And maybe I should only have 2 sig digs here. So if that was the case, then I would have 1.4 amps. Okay, so that's a two-step problem, a very common type of question that we would see in Science 30 and on the Science 30 diploma. So good luck with those, you guys, and I'll see you next time.